Hello, everyone. I hope everyone is safe at home and observing the guidelines for social distancing. I guess on Friday we're going to have some reprieve where some retail stores and other facilities are going to open. So we're all in this together. Last week, 7 Armenians were among a group of scientists at JPL which with NASA developed ventilators. As we've heard, these are things that are in short supply during this crisis. So today, my guest is Arbi Karapetian, who is an engineer at JPL, and he's going to talk about this entire process and how it all came about. Hi, Arbi, how are you?
Hi,
Thank you
Ara.
for coming and joining us. This is very important.
My pleasure.
Tell us a little bit about this whole project.
So I think it's now about 7 or 7.5 weeks ago. Uh, One of our engineers at JPL in Pasadena uh, talked to our chief engineer at JPL and said, "Hey, from what I hear, there's going to be a shortage of these ventilators to treat COVID-19 patients." And so that's something that we could tackle. We have the technical expertise here, and we can certainly tackle that. That conversation turned into another conversation, and it snowballed into JPL management saying, yes, this is something that we are going to take on. And they sent out a request for volunteers to come and join this newly formed project. And then there was a number of people that were asked to join the project, and so the team sort of formed organically. We came together. Obviously, all of us were adhering to the safer at home request from the government. So we started figuring out how to do remote work from home with a very limited number of people actually going into our lab to be able to put things together, the physical manifestation of what we were designing together. So as we would as a need for a specific expertise would come up, I'd pick up the phone and call up, my contacts in that department and say, hey, we're looking for, the crackest thermal engineer we have. And sure enough, moments later, a thermal engineer would appear, and they would just go at it, and that's kind of the nature of how the team formed.
You said you were working from home. I mean, is it just on computers? You're doing the design? How does the building of this happen from home?
So, we use collaborative tools. The the process for this, and I will say, right, at NASA JPL, we build spacecraft. We don't know anything about medical devices. That's just not something we do. But one of the things that exists at JPL is the expertise and the ability to take a problem that we don't know anything about and defining it in a way where then we can tackle that defined problem and come up with a solution. So it's analogous to space exploration in a way where, if we plan to land on the surface of Mars or on the surface of Europa, there just isn't a place where you can go to get all the information about what all that entails. So what we've become good at is defining problems that we don't know anything about. Now, I will say that ventilators are something that has been figured out a long time ago. It's just that for us, it was a novel problem because none of us had done it before. And because the time was so short, we were able to sort of jump in, get some experts to advise us, learn as quickly as we could. And so all of that happened over teleconferencing. All of that happened using online tools like, Google G Suites to be able to, edit documents and requirements and kind of look at all that. And then, of course, we use design tools that are designed for collaborative efforts going on at the same time. So everyone was able to contribute from working remotely at home, but also working towards the same design using collaborative tools. Now, in the end, the manifestation of all this, intellectual work that goes into design has to come into a physical thing. And so because of that, we had somewhere between, 7 to 15 people at a time, obviously observing all the social distancing and personal protective equipment, requirements going into lab, and then putting the things together. So it was the majority of the team supporting the handful of people that were on lab, but also just working kind of remotely in a collaborative way.
So you said, if I understood correctly, that it took you 7 weeks to develop this. How long is it going to take to manufacture this and actually get it to the hospitals that need them?
So I think one of the things we've been doing is keeping an eye on what the current need is in the United States. And so, as you can imagine, all of these predictions are based on mathematical models. And so the mathematical models that we were using earlier on had some worst case scenarios that were showing a very large need for extra ventilators. The current models, which are affected, by the way, by all the social distancing we've all been doing, doesn't show that there is a huge need for ventilators in the United States, but they are projecting that there'll be other countries that would have a need for them. There's also a part of the predictions that's showing a secondary hump coming in the United States, which that may be useful. So, NASA JPL doesn't produce anything more than two, right? We build spacecraft. They're one of a kind. And so the model that NASA JPL has decided to go forward with is that we came up with a design. We got the FDA emergency use authorization for it. And now we are turning our efforts into being able to license this design royalty-free to any qualified companies, be it internal to the United States or external to other countries, to be able to manufacture these in large numbers. And so that's sort of the phase we're going in, is we're putting together all the licensing packages so that we can do this technology transfer, and it'll be a no-cost technology transfer to those manufacturing companies to produce them in the thousands.
Okay. It's always good to hear that Armenians have been involved in some kind of innovation. But you said you basically, on an as-needed basis, kind of pooled your resources. Are these Armenians both at JPL and NASA, or they're at your team that you've put forward?
So the team that we worked with is primarily at the NASA JPL Center in Pasadena. We had a couple of people outside, but it was primarily the people that work in the Pasadena office of the Jet Propulsion Laboratory. So I am the deputy section manager for the payload and small spacecraft mechanical engineering section, and within that there's a few Armenians that work there, and so just organically those people were pulled into this job, and they became key people in being able to implement this solution. A lot of them were actually going into the lab and affecting it hands-on, and then as the need would come for pulling in talent, inevitably another Armenian name would pop up. And so I could say that 3 of the folks are in my section, and their expertise is what pulled them in. And then the rest of them, we needed a couple of crack thermal engineers, and so I contacted some of my colleagues in thermal engineering, and then suddenly a couple of thermal engineers appeared, and one of them was Razmik, and he jumped in, and he was instrumental in helping us get to the finish line.
That's great, and thank you for all your work. But I want an update. Asbarez covered another group of scientists, among whom were Armenian and you, about 8 years ago on the Mars rover project. How is that moving forward?
Good. So, that was the Curiosity rover that's been roving Mars for a number of years now, and it's doing great. It's still exploring the red planet, and we are about to launch the next Mars rover, which is the Mars 2020 rover that will be launching in July of this summer. And so we've been pushing the envelope on that. So stay tuned for the world's first extraterrestrial powered aircraft on Mars. It's a Mars helicopter that it will be carrying, and that's going to be very exciting.
We're going to check back in with you in July. Hopefully, all of this social distancing will be over and we can meet face to face. Thank you,
Absolutely.
Arbi, very much for taking the time. This was very informative. And stay safe, you and your family, of course.
Thank you, and you as well.
Okay, take care. Bye bye.
Bye bye.